Swayam Prabha. Digital India. Educated India.
Hello dear learners, welcome to the session of Managerial Economics. I am Dr. Supriya Jain, working as an assistant professor in the Institute of Business Management at GLA University, Mathura. So, let us begin with our today's lecture, and as you know, we always revise what we have covered in our previous session. So, here let us have a look on our discussion in our previous session. We have talked about economies of scale as well as diseconomies of scale. Economies and diseconomies of scales arises when we increase the operation, when we increase the size of output in our organization, and at working at the large scale we say that initially when companies increases their size of output, they get several economies, that means they are getting several advantages which helps in the reduction of cost. So, here we have studied this heading economies of scale in two categories, one is internal and second is external. Internal economies arises because of the size of the firm, right. If you are working at the larger scale, then definitely you will be able to get certain economies which will help in the reduction of your average cost. Whereas, external economies arises due to size of the industry, not a firm, right. So, whatever benefit you are going to get because of which your average cost reduces, that is not because of your own operating size, but the size of the industry and the growth of the industry taking place. Whereas, diseconomies are again you can say the disadvantages which will be there when you further increase the size of your operation. Now, here you will see that your average cost curve will not decrease, it will rather go upward, right. So, this happens when you unwidely spread your operation and there becomes a problem in the management. So, again internal diseconomies arises because of large scale of operation of the firm, whereas external diseconomies arises again because of the size of the industry, not the firm. So, we have understood these concept of economies and diseconomies of scale, and thereafter we have talked about economies of scope, right. What scope a business firm is having if they are producing more than one product, right. How economically it will going to help them if they are going to start up with any kind of a complementary goods where they can use the similar inputs and the machine for the production of the another commodity. So, here we have also talked about the economies of scope, and we have also understood the relationship how we are going to start with the production of the combination or you can say the product which can be jointly demanded, right. And then lastly, we have talked about cost and learning curve. Learning curve is basically helping us to understand by the way of learning, by the way of doing, right, how we would be able to enhance our experiences, our knowledge to do that work in a better way, right. We can think of better productions, we can think of better methods and technologies which will help in the reduction of the cost. So, this was our discussion which we have made in our previous session, right. We have understood the concept of cost clearly. So, now in this class we are going to start with the production, right. What is meant by production, right. So, let us look at the learning objectives of our today's session. Here you will be able to examine the economic analysis of firm's technology which is used for different types of input and the process of production. So, here you will get an idea about what production is and how you can use these firm's technology in the production of different commodities. It will also help you to develop an understanding to the distinction between the short run and the long run production function. Definitely, like we have studied about the short run and long run cost and output relationship, here you will be able to understand how production is going to get work in short run as well as in the long run, and for the better understanding of the short run, you will be able to develop a critical appraisal of the law of variable proportion as well as law of return to scale. Thereafter, I will introduce you to the concept of isoquant. ISO cost line, marginal rate of technical substitution, elasticity of substitution and expansion path. So, these are the headings which are going to be discussed in this session, and you will get a clear idea how you will be regression answers, right. So, these are the learning objectives of our session. Let us begin with the very first topic, where let us first understand the meaning of production. How are we going to understand what production is, right. Simply, if you want to define, production is a process, right. What is production is? Production is a process of converting input into output, right. So, that is what is basically called as production. But if you are going to understand in a better form, you can say that it is a transformation of resources, right. It is a transformation of resources into the goods and services, right. You have inputs. Now, these inputs may be of no use, but by the way of this production process, you are converting them into goods and services which are having value and which will be able to satisfy the needs and wants of the customers. So, in other words, you can say that production is an act of transformation of inputs into output, okay, which will help in the satisfaction of wants of people. Like for example, input of sugarcane, capital and labor are used to produce sugar, right. So, sugar is basically the refined form which we are using. So, how we made it? We made it from the sugar cane, as we all know, this is the raw material used for making sugar, and we are converting it by using the capital as well as resource these labors, right. So, production also includes production of services. Production does not only include the production of goods, but it also includes the production of services, like we have industries of services, we have lawyers, we have teachers, we have doctors. So, they are also providing services which provides utility to the people, right. So, in short, you can say production is a process of transformation where we are transforming inputs into output, and the purpose of transforming these inputs into output is to satisfy the needs and wants of the consumers, okay. So, we have these definitions also for production given by economists. So, very first definition is given by James Bates and Parkinson. According to them, production is the organized activity of transforming resources into the finished good, right. So, this is a process basically which you have organized, how you are going to transfer the resources into the finished product in the form of goods and services, and the objective of production is to satisfy the demand of such transformed resources. So, this is how we have understood the meaning of production also. So, I believe this definition is clear to everyone. And looking at the second definition, which is given by J.R. Hicks, production as any activity, whether physical or mental, which is directed to the satisfaction of other people want through exchange. Okay, yes, obviously to purchase these goods and services you have to make the payments, right. So, there will always be an exchange taking place. You can't avail these output or the services or goods which are being produced by the process of production. Definitely there will some exchange taking place, but whatever the activity you are producing, whether it is physical or mental, in the form of physical goods or in the form of services, the satisfaction which you are going to derive out of it would be termed as production. Moving ahead, we have production function. Now, what is meant by this production function? Production function, like we have talked about demand function, we have also discussed about supply function. So, I believe now you will be able to understand how we are going to relate this production with the function. For the production, we requires factors of production, okay, because production cannot be possible without the factors of production. And what are our factors of production? We have land, labor, capital, machinery, right, entrepreneur. So, these are all the factors of productions which we are using for converting our input into the output, right. So, now we are going to understand how we are going to establish the relationship between the production and the functions on which the production is based. So, the functional relationship you can say between the physical input and physical output per unit of time under a given state of technology is called as production function, right. So, how you are going to establish the functional relationship between the production and the factors of production? within a specified period of time, like it is already written per unit of time under a state of technology. Yes, this is again very important for us to understand that production function we are defining with the given state of technology and how we are going to convert these inputs into the output with the available factors of production. So, it can also be expressed in the form of mathematical equations where you can say that output of any commodity is a dependent variable for obvious reason, because it is the functions of other variable and definitely the inputs are the independent variable. So, if we are defining it mathematically, we are writing it like this: quantity is the function of A, B, C and N, right. So, these are the number of factors of productions which we are using for our production purpose. So, where Q denotes the quantity of the commodity that is produced within the period of time, right, and F stands for the function, and A, B and C denotes the various quantity of inputs which we are using to convert them into output. Okay. So, looking further with the production function and to understand it clearly and to apply it, we have to make certain assumptions, right. So, what are the assumptions which we are making for the study of production functions? The very first point says that it is specified with reference to a specified period, right. So, whatever we are having during that period of time, so it is very important to understand if we are defining the production function, that has been defined for the specified period of time, right. So, time plays a very important consideration here. Secondly, we assume that the state of technology remains the same during the period. So, for the period for which we are calculating this production function, we assume that there is no change in the state of technology. Whatever the given technology is there, we are working with the same technology and there will be no change, right. So, this is the second thing which we are assuming. And the third point says that it is assumed that firm uses the best and the most efficient technique available in the production. Yes, this is again to get the best, we are putting the best use of our resources and the best efficient technique which is available to us, right. So, that we would be able to produce the goods and services which are able to satisfy the maximum needs and wants, and we would be able to get the best of our production. So, this is the assumption which we are making, that the producers are behaving rationally and they are using the best and the most efficient technique of production available to them. And lastly, it is assumed that the factors of production like land, labor, capital, right, all these factors of productions are divisible into viable units, right. Then only we would be able to establish this functional relationship between demand and its factors, okay, or the inputs which we are going to use for the process of production, right. So, I believe these assumption functions are clear to every one of us. Now, looking further, how we are going to see that production function is going to work, as there is always a specified period of time. So, we need to understand these production function keeping the different time frame, that is the short run as well as the long run. So, as we know, short run is a period where some inputs like plant, size, machine and equipments cannot be changed. This we have already understood, that in short run we always have some inputs which are fixed in nature and we have some inputs which are of variable nature, right, because short run again is a time frame which is not enough for us to change to a new situation. So, when we talk about a plant size, right, overnightly we cannot change the size of our plant, or it cannot be done within a day or two, it requires a considerable time, right. So, short run is a frame where we assume that or we have to believe that plant size, machine, equipments, all these inputs are of capital nature, and these are the fixed factors which cannot be changed, right. Whereas, the other factors like raw material which we are using for the production of those goods are of, or the labor you can say, are of variable nature, right, which can be varied, which can be increased, right, in a shorter period of time. So, we can say that therefore, a producer trying to increase the output in the short run will be able to do so by increasing only the variable input. So, here we need to understand, if a producer wants to increase the size of output in the short run, then the only choice which left with the producer is to increase the variable inputs only to increase the size of output, because we cannot make change to the fixed inputs. Fixed inputs in short run will remain same, and whatever the change we are trying to make in the size of output, that we are able to do with the increase in the variable input. So, on contrary, you can say long run input options are very wide, because long run is again enough time for us to change to our new situation. So, in long run there will be no fixed input, all the inputs are variable. So, here you have better understanding and you have better way of increasing the size of your output, because all the inputs are variable. So, based on these characteristics of input, production functions, basically we are going to talk under two categories. The one is production function with one variable input, right, when we are having only one variable input and the other input is fixed. So, this is what basically we are going to study, the production function in the short run. And the second is when production function, when we have two variable inputs, we have two inputs, one is means both of them are variable, okay, we can change both of them. So, because of this we have no fixed input in the long run. So, for this production function with one variable input, this can be clearly studied with the two laws, where we have law of variable proportion and we do have law of return to scale, right. Whereas, when we talk about production function with two variable inputs, we will talk about iso cost curve, right. So, here further to understand these production function, when we have one variable, we will study these two law, and when we have two variable input, we will study it with the help of iso cost curve, right. So, now let us start with the very first, where we are going to talk about production function with one variable input. Now, as you can clearly see, this is the situation we are talking under the short run. We have only one input which is of variable nature and the other input is fixed input. So, in short run, producer must optimize with only one variable input, okay. Whatever the maximum optimization a firm can do, it can do only with the increase in one variable input. So, for this understanding, let us have one situation. So, let us consider a situation that there are two inputs, okay. We are making an assumption, say we have two input and these two input, one of them is a capital and the other one is labor. So, what we have seen that our fixed input is capital, okay, or you can also denote it with K, and our variable input is labor, right. This is the input which we can change, labor size can be changed in the short run, but if we want to increase the size of our operation in the short run is not possible, right. So, we have seen that capital is of fixed nature, whereas labor is a variable input. Now, you will note that as the amount of capital is kept constant, right, because here the capital is being constant, it cannot change, right. So, the labor is increased to increase the output, and the ratio in which these two inputs are used will also change. Suppose initially we were using 1:2 ratio of labor and capital. Being capital a fixed input, we cannot increase the size of capital, we can only increase the size of labor to increase the size of output, right. So, if suppose I have increased the labor, being capital constant, it is a fixed input, so I have increased the labor. So, see the ratio will also change, right. The ratio between these two variables will also vary, because we are only making an increase in the variable input to increase the output and keeping a fixed input to be fixed, right. So, therefore, any change in the output can be manifested only through a change in the labor input, right. So, whatever the change is taking place in the output because of change in the labor input, we can easily relate that we have increased this variable, and with the increase in the variable, this output has been increased. So, that relationship can be easily find it out, right. So, a production function is also termed as variable proportion production function, because this has been based on the variable input. So, that is why this name is being given to it. It is also termed as variable proportion production function, and it is essentially a short term production function, because here we have one fixed input, and fixed input concept is only applicable in the short run, right. Now, let us look at how we are going to write this production function with one variable. Q here is the quantity, and as we have taken only two input, one of them is labor and other one is capital. We are denoting capital with K here, right, fixed amount of capital, as because this is the fixed input and this is the variable input. Now see, whatever the change is going to take place in the quantity, that is because of the labor, because this is the variable input and capital being the fixed input, this is not increasing, right. We are only increasing the size of labor to increase the size of output or our operation. So this is how we define the production function with one variable. Now let us look at the total, average and marginal productivity of factor input. How are we going to find out? See, whatever the change we are making into our variable input, so how this variable input is going to affect the total, average and marginal productivity of the factor input, right. So assuming, as we are assuming capital to be constant, this bar need to be shifted here, this capital needs to be constant, this is not here, and labor is a variable input. So you can see total productivity of labor, since we are going to talk about labor only and this is the only variable which we are changing. So the total productivity of labor is the function of capital and labor, and where capital keeps fixed, okay, keep being a fixed input. Whereas to calculate the average productivity of labor, what we are going to do, average we always divide the total by the quantity, right. So average productivity of labor can be finded out by this simple formula, where we are finding out the total productivity of the labor divided by the total number of labor we are using, right. And then we have marginal productivity. So if we want to find out the marginal productivity of labor, again this can be finded out by change in total product, whatever the change has been taken place in the total output upon the change in labor, right. So one additional unit of labor if you have added to your production, then because of that what increase has been taken place in the output, that will be called as marginal productivity of labor. So these are the three important consideration which you need to understand. How are we going to calculate the total, average and marginal productivity of a factor input, right. So now these are going to be studied further in this law of variable proportion. How we are going to understand this law of variable proportion? This is a part of production function with one variable which is applicable in the short run. So short run production function, as you know, is governed by the law of variable proportion, and we have also discussed why this law is called as variable proportion, because here whatever the change is taking place in the output is because of the change in the variable input. So here we have one example to make this clear to every one of you. Let us assume there is a manufacturer, right, and this manufacturer starts the production with the investment of 40 crores in the plant and machinery, right. This person has started his business by making an investment of 40 crores in the fixed input named as plant and machinery, and the annual product of the firm is shown in the table. I will be showing you the table. Let us read out this, what is written here. So we can see that as a manufacturer increases the units of labor, keeping the investment in the plant fixed. Since we are talking about the short run, so the investment which is being made by the manufacturer for this business is the 40 crore, keeping this as a fixed input, and we have on the other hand the labor, where we are only increasing the size of labor to increase the size of output. So here we have this chart to make you understand about this law of variable proportion. So now you can see we are not considering the fixed input, that is the capital, because that will remain the same, there will be no change taking place in it. What we are doing here is we have written the labor in a unit form, okay. This is the total product, marginal product and average productivity, okay. What change will be taking place in the total productivity, average productivity and marginal productivity? Because of change in the size of the labor. So when we have added when we were having 1 unit of labor, so their total productivity was 20, there is no marginal productivity, and again the average productivity of the labor will be same. But as when you have added the another unit of labor being a variable input, you can only increase the size of labor, right, you can only increase the size of variable input to increase your output. So when you have initially added 1 unit of labor, you can see the total productivity increases, marginal productivity is 30 and your average productivity also increases. Now further, when you added 1 more unit of labor, again this total productivity increases, marginal productivity increases and average productivity also increases. So, you can see that this is the stage 1 which we are calling as an increasing return stage, where when you are adding the successive unit of labor to it, the productivity, total productivity, marginal productivity as well as average productivity of a labor keeps on increasing. That means a little change in the input will gives you higher change in the output. Now, moving ahead, when we further add labor or increase the labor in our organization to increase the output, see our product productivity is still increasing, but our marginal productivity starts to decline. Now, it reduces from 40 to 30 and our average productivity remains the same. In both the cases it is same, right. Then further, when we added to the 5th unit of labor, our total productivity increased, our marginal productivity is still declining and average productivity also started declining. In the previous case it was same, but now as you can see it is also started declining, right. When we add the another unit of labor, the total productivity is still increasing, but now marginal productivity also decline and average productivity also decline. So, basically what we are calling this stage would be called as a stage of diminishing return, right. The returns you are getting, that is in the diminishing form, because the total productivity of that product is increasing, of labor is increasing, but if you look at the marginal and average productivity of the labor, it is declining, right. So, you can work up to this phase because still you are getting some return, but inputs are proportionately uses where you are not getting more of the output, but definitely you are getting some of the return to it. In the first case the output was in a higher proportion, here the output you are increasing, but in a lesser proportion, that is why we call this stage as an diminishing return stage. And lastly, you can see here, now if you are going to further increase the size of input, right, your total productivity will not increase. In the very first case you can see it remains the same and then thereafter it also started declining and the marginal productivity reaches to 0, right, and it might reach to negative, and here average productivity also keeps on declining. So, this is basically the stage of negative return. So, what we are trying to make you understand here is, in short run, like we have studied, we have two inputs, some of them are the fixed inputs, means one of them is the fixed input and the another one is the variable input, and whatever the change we can make, we can only make it to a variable input to change the size of output, right. And when being one input fixed and being the other input variable, you increase only one of them, then the proportion, the ratio between these two inputs will change drastically. So, initially it will give you the return which is a very good return you are going to get, which is named as increasing return, but thereafter your return starts declining, right. That is why you are getting the returns, but in a diminishing form. So, we are calling it as a diminishing return, but if you further increase it, you will get negative returns, rather than getting something positive it will give you a loss, and that is why our average cost curve shapes like U, right. So, basically you can say that in short run these economies and diseconomies does not work much, but yes they are applicable more in the long run, right. So, if we talk about from a consumer from the producer's point of view, we can say that if we want to increase only the variable input to increase the size of operations, then up to this point we can increase and we can go up to this point, because here also we are getting the return, maybe in a diminishing form we are getting, but beyond this point we should not add further increase in a variable input, because from here maybe we are going to get the negative return. So, this is how we understand the law of variable proportion, which is applicable in the short run. So, this is all we have discussed with the explanation of the table I have talked about, right. As we know that in the variable proportion state that increase in the quantity of the variable factors, marginal and the average product will eventually decline, other inputs remain unchanged, right. Moving ahead, let us look at these graph, right. How we are going to plot this tabular representation of our law of variable proportion in the form of graph. You can see here we have total productivity, we have average productivity and here we have marginal productivity. So, we have 3 stages, right. The first stage is of increasing return, the second stage is of diminishing return, and the third stage is of negative return, right. So, initially when we increase the variable factor, see here on the y axis we are showing the output, because the output will be changed because of change in the variable factor, right. So, initially when we increase the size of labor, we will get an increase in 3 of them. Total productivity will increase, average productivity is also increasing, and marginal productivity is increasing. But in the stage 1 we are also getting this point of inflection, and this point of inflection says that up to this point there is a increase in the total productivity, which is very high, right. It will increase at a increasing rate, and thereafter it is increasing with the diminishing rate, and then it also starts falling, right. And if we talk about stage 2, stage 2 is the stage which started with when average productivity is equals to the marginal productivity, right. Your total productivity is greater than both, but here in this stage it will start from the point where your average productivity is equals to the marginal productivity, and your third stage starts where the marginal productivity is equals to 0, right, because you are not getting any additional benefit by adding further more successive units of the labor, right. So, this is how we explain the law of variable factors through this graph, and here we have all the 3 stages which are being explained. As you can see in the increasing return to variable factor, here in the first case marginal productivity is greater than 0, and marginal productivity was also greater than average productivity. You can see this is the curve of marginal productivity and this is the curve of average productivity, right. So, here in this case marginal productivity is greater than average productivity. We are talking about the stage 1 of increasing return. Whereas, if you look at the second stage, see what is written here. Now, the marginal productivity is lesser than average productivity, right. So, stage 2 where we are getting the diminishing return, here your marginal productivity is lesser than the average productivity, right, and it starts from the point where marginal productivity was equals to the average productivity, right. And then if we talk about the negative return stage, negative return is the stage where marginal productivity will be below than the 0, right, because it goes to the negative, right. Even if you are further going to add, first it reached to the 0 point, and if you are further going to add the labor to it, then it might reach to negative. So, here total productivity also starts falling, marginal productivity will lesser than be 0. So, you can say that stage 3 is technically an inefficient stage of production, right. We should not be try to get into this stage, because this is an inefficient stage. Unnecessarily we are increasing the size of labor input, but we are not getting any return on our output. So, rational firm will never operate in this stage, right. So, this is what is being explained through this law of variable proportion to understand how we are going to plan out our production in the short run when we are having one fixed input and we have another variable input, up to which point we should be increasing our variable input, so as we would be able to get good returns, right. So, stage 1 shows you the increasing return, stage 2 shows you the diminishing return, and in the stage 3 if we are reaching and if we are operating, trying to operate into this stage, then we will get negative returns, right. So, to understand the production function with one variable, we have this law of variable proportion. Now, we are going to understand this production function with 2 variable input. When we have 2 variable inputs and we can change both of them, we have no fixed input, right, both the inputs are variable, then how we are going to examine the results on the output. So, law of return basically helps you to examine the production function and the input output relationship in the long run, where increase in the output can be achieved by varying the units of all factors in the same proportion, right. Here now you can change the capital, you can also change the size of labor, because we are operating in the long run, and in long run no input is a fixed input. So, in long run all the factors become variable, that we already know, and it means that in the long run the scale of production and the size of firm can be increased. So, let us have a look to this law of return to scale, right. Earlier we have talked about law of variable proportion, where we have understood the production function with one variable, whereas in law of return to scale we are going to talk about production function with two variables, right. So, here we have the units of labor and capital, since they both are variable input. So, we can change the capital also and we can change the labor also, and now here we are understanding with the change in the capital and labor both of them what return we are going to get, right. So, if we have initially changed both capital and labor input and we have added 1 to it, then in the first case marginal productivity and total productivity will remain same, but and in the second step also, when you have increased it further, the marginal productivity is increasing and the total productivity is also increasing, right. When you have added the third unit to it, the total marginal productivity is still increasing and total productivity is also increasing. So, this is basically the stage 1, which is going to give you the increasing return whenever you are making a change in the capital and the labor. Now, further if you are going to make change in the capital and labor, your marginal productivity will remain same. It is not going to add any further productivity to it, and still your total productivity is increasing, but you can see your marginal productivity is constant, right. That is why the second stage is called as the return of constant return, right, the stage of constant return. Here whatever the return you are getting, they are of constant nature, means your size of output is increasing, but your marginal productivity will remain same, and that is why the stage 2 is being called as constant return. Then further if you are going to add any change into the labor as well as the capital, your marginal productivity will decline and your total productivity is still increasing. So, we are basically relating it with the marginal productivity, the additional unit of labor as well as capital, are they giving you any kind of return or not. Initially the returns are increasing, secondly we are getting the constant return, and in the third stage we are still getting the return, but we are getting it in a diminishing form, right. So, you can see the difference between the law of variable proportion and law of return to scale. There, because we were only increasing the variable input and the capital remain the fixed, right. So, the ratio between two changes at every stage, right. So, that is why we were getting the increasing return, and very first stage would give you the diminishing return, second stage, and in the third stage there will be a negative return. So, in this law of return to scale, since we have both the variable factors, so we are increasing both of them, capital is also increasing and labor size is also increasing. So, here we will get the returns, but definitely our return will be different, like here we are getting increasing return, here whatever the returns we are getting are of constant nature, and here also we are getting the return, but they are of they are being called as diminishing return. So, you are not working in any of the negative situation where you are not getting any sort of return. Your return will be there, but definitely the return will be different at different stages, right. So, increasing return of scale says that you have increased the input by 10%, a lesser change in the input gives you the more change in the output, right. Means small amount of change you have made in the input, and the return which you are going to get in the form of output will be changed very much, or it will change to the higher percentage, right. Whereas, constant return of scale says that you are increasing the size of input by 10% and output also rises by the 10%, means same return you are getting, right. That is why we call it as in constant return. Okay, the size of input you are increasing, the same change is going to take place in the output, right. Whereas, in the form of diminishing return, you can say you are increasing more of the input and your output rises only by 10%, means here more of input are being used to increase the size of output, but in a percentage you can see it will be lesser than the change in input. So, I hope it is clear how we are talking about the returns we are going to get when we are producing with the two variables, when we can change both of them. We are getting the return, but initially with the lesser inputs we are getting more return. In the second stage we are getting the same return, the percentage increase we are making in the input, the same percentage change is going to take place in the output. Whereas, in the diminishing return more change you are making in the input, but the lesser effect you are getting into the output, right. And this is how we basically draw this curve of law of return to scale. Here you are getting the increasing return, this shows the constant return to scale, and this shows the decreasing return to scale, right. So, these are the different stages which we can see and we can draw graphically, right. On the x axis we have shown the labor and capital, because these are the inputs where we have made the variation, and we have seen the change on the marginal productivity, right. Initial stages we have seen the marginal productivity increases, then it become constant, and then thereafter it started decreasing, right. Now, let us talk about the production optimization, right. These are the two functions which we have studied. Production function with one variable, where we have talked about law of variable proportion, whereas the second was your production function with two variables, where we have seen the law of return to scale. Now, we are talking about the production optimization. See, the ultimate objective of a producer is to optimize the available resources, because they want to produce the output, how much output they want to produce, and how they are optimally utilizing the resources they are having, that actually matters. So, iso-quant are the ways where we are going to understand the optimization, how producers get their optimization, and this iso-quant is basically a Greek word which comprises of two things. One is called as iso and the other called as quant. Iso means equal and quant means the quantity, right. Equal quantity, or how we are going to get the equal quantity by using the different combinations of our input, right, to produce a given level of the output. With this you can see here the quantity is fixed. In the for the law of variable proportion, when we have seen that in that quantity is the function of labor and capital, and in the short run capital being a fixed input remain fixed, right. In law of return to scale we do not have any of the fixed input, we can make a change in labor as well as in capital. But here in the iso-quant what we are saying, the quantity is given, quantity is fixed, that we need to produce up to this much of output, and how are we going to produce this much of output with the different combination of input. So, here we can increase the size of labor also, and we are also increasing the size of capital, or you can say the combination which we are using for labor and capital to produce the given level of output. So, for that we are going to understand this iso-quant curve, right. So, iso-quant curve can be studied with this table, how we are going to draw it and what is meant by iso-quant. You can see here we have the combinations which we are going to plot on the graph, and this column shows the output. Like I said, output is given, it is constant. Here you want to produce 200,000 tons, again in the second it will be same, third, fourth and fifth. What are you doing here is, you are using the different combinations, right. You are using the different combinations of capital and labor to produce the same level of output, right. Here suppose you have 40 crores of labor capital, and you have 600 unit of labor to produce 200,000 tons of output, right. So, what you have done, for increasing the labor size you have reduced the capital. So, this combination will also produce this much of output, this combination of labor and capital will produce this much of output. So, you are saying that we are using capital and labor as a substitute for each other. If we are sacrificing one of the factor, then we are increasing the another, right. So, to basically have a same level of output. This choice can be made by a producer, what combination the producer wants to use for the given input to produce the given level of output, right. And this is how we basically show the iso cost curve or iso quant curve, right. Iso being equal and quant means the quantity. On the x axis we have labor and on the y axis we have capital. Since we are using the different combination of labor and capital to produce the given level of output, and like I said, we are treating these two inputs as a substitute of each other, where if we are using more of capital, then we are using less of labor, and if we are using the less of capital, we are increasing the size of labor, right. So, the curve which we are going to get is called as iso-quant curve, right. Now, let us look at the properties of iso-quant curve. How are we going to study this iso-quant curve, And here I would like to help want to recall that we have talked about indifference curve also when we have talked about utility concept, right. There in the utility concept, and when we have talked about ordinal utility, we have seen the indifference curve, how a consumer remains indifferent between the combination of two goods and what combination they are using, so as they would be able to satisfy their maximum needs and wants. Same is the case of the isoquant. Here the producer, we are talking from the producer's point of view, and there we were talking from the consumer's point of view, right. So, how producer is going to combine these two input in a manner where the producer is able to optimize its production. Okay. So, the very first point says that isoquants will always be downward sloping. Like we have seen the curve of isoquant, this is downward sloping curve, which represents that both the product x as well as y, not products but the inputs rather I should say here, because we are talking about production, right. So, x input and the y input are being used as the substitute of each other. If we are using more of y, then we are using less of x, we are using more of less of y, then we are using more of x. So, these are the basically different combinations we are making out, so as we would be able to produce the given level of output, right. So, the very first property says that isoquants will always be downward sloping. Second is higher isoquants will represent the higher output, right. So, again this is one isoquant. If I draw the another isoquant over it, then we can say the highest the topmost isoquant, this is isoquant 1, this is isoquant 2, this is isoquant 3 and this is isoquant 4. So, this isoquant 4 is going to give you the maximum output, higher output. The more will be the isoquant, the higher will be the isoquant, higher will be the output, definitely, because at this point you are using more of input y and you are also using more of input x, right. Next is isoquant will never intersect. So, as if we are drawing the isoquant, we are drawing them parallelly, right. We cannot say that the isoquant will intersect like this, no, they will never intersect. There is no point of intersecting between the isoquants curve, because the inputs which we are making, right, we are very much clear how we are going to use the different combinations of these inputs, because of the marginal rate of substitution is there, and we are clear with how much capital and labor we are going to combine to make the given level of output. So, that is why the isoquant will never intersect, right, because this signifies that single input combination producing two level of output. And then lastly we are saying isoquants will always be convex to the origin, right. This is how we draw this isoquant curve, this is the convex shape, and if you would be drawing it this way, then it will give it a shape of concave. So, it is not a concave shape, it is a convex shape, which says that the products are two products cannot be perfect substitute of each other, right. This is the shape given to them, they are being treated as a substitute, but in general we cannot say that the capital is a substitute of labor or labor is a substitute of a capital. Though we are defining different combination of these two commodities, but they are not the perfect substitute of each other, right. So, this is how we basically understood what is meant by isoquant. Isoquant is basically used when a given level of output is being produced with the different combinations of input, right. We can make a change in both the inputs, because this is again applicable in the long run, but here you need to make sure what combinations you are using to attain the given level of output, right. And for the clear understanding of isoquants, we have seen the different properties, that it will always be downward sloping, higher isoquant will represent the higher output, it will never intersect each other, and they will always be convex to the origin. Then let us talk about the isocost line. What is meant by isocost line? Students, if you recall back, we have also talked about the budget line, right, as because consumers have a constraint of their income. So, income of a person draws the budget line, same is the case, producers also have their own budget of producing any commodity, right. So, they need to understand how much commodity, how much output they can produce with the given level of the input. So, this iso-quant line is basically the locus of point of all the different combination of labor and capital, and the firm can employ for given total cost and price of the input, right. So, whatever the cost is going to be involved, you need to understand your iso cost line, that this is the area which is feasible for you. You can here use the different combinations of given input, and that is the point which you cannot use because you do not have that much of resources available to you. So, iso cost line is basically helping you to define that boundary within which you need to use the different combinations of input which was available to you, so that you will be able to optimize them to the maximum, right. So, this is what is basically meant by iso cost line, and how this iso cost line help you to draw this producer's equilibrium, right. So, producer equilibrium is a stage where producer is in the equilibrium form, right, where producer is able to utilize the available resources to the maximum point which he or she can opt with the given budget or with the given iso cost line, right. So, one thing which is important to keep in the mind, that production function describes technology, not economic behavior, right. When we are talking about production function, it is defining the technology, the given state of technology we are having, but it is not defining the economic behavior of a person. And as we know, iso-quant would show all technically efficient combination, okay. The different combinations which we have made on the iso-quants, they are all technically efficient combinations, whether we choose A, we choose B, we choose C or D. These are the technically efficient combinations which can be used to produce a given level of output, right. But when producers are faced with several technically efficient combinations, the decision is basically based on the economic efficiency. So, these are all the technically efficient combinations which are already available to us, but when we have these all technically efficient combinations, what we will do? We will make a decision based on economic efficiency, that is the use that combination which minimize the cost of production, okay. All these combinations are available to you which you can use, but definitely you are going to choose that combination where the cost of production will be minimum. So, ultimately producers focus will always be on the reduction of cost. How are we going to go ahead with the output? What combinations of input should be utilized so that a firm is able to minimize their cost of production and they would be able to maximize their size of output. So, for that we are talking about this producer's equilibrium. So, hence to be economically efficient, a producer must determine the combination of inputs that produce the output at the minimum cost, because ultimately the focus is on the reduction of cost. So, a profit maximizing firm will try to use a combination of input that will minimize its cost of production at a given level of output, right. So, if output level is being given to you and you are using the different combinations of input, then you need to understand how you are going to combine these two inputs which are technically efficient, as well as economic efficiency should also be there, where you would be able to minimize the cost, right. Now, looking further, we have this producer equilibrium curve, where I will make you understand how we are going to talk about the slope of iso-quant and also talk about the slope of iso cost line. This is the iso-quant, you have already seen, this is the iso-quant curve which shows the different combination of goods which can be produced, right, which can be produced for the given level of output. Whereas, we have iso cost line which is defined as a budget line for a producer, how much resources a person can employ. Suppose if we see that this is the budget, this is the iso cost line for a consumer, for the producer, because this is a producer equilibrium curve, right. So, this is the iso-quant line. out of this line, if we talk about this R point and this T point, this is not feasible because our budget is beyond that point, our budget is not beyond that point. This is basically the unfeasible area and this is the feasible area where we can have the different combinations of good like labor and capital, right. So, at the point M we can say the producer is in an equilibrium position, because if they are using below to this, that means they are not utilizing their resources efficiently, right. They have more resources, but they are not utilizing those resources efficiently. So, ideally below this point any point will not work. So, at the point where iso-cost curve and iso-cost line touch each other, that point would be called as producer's equilibrium point, right. This is the producer's equilibrium point, right. So, up to this point if the producer is working, then they are going to get the maximum optimization, and for that reason we are studying this producer equilibrium point, where you would be able to find out, where the producer is able to find out up to which point they should produce or what combination of given commodities they should make, so that the cost of production will be minimum, right. The focus is on the reduction of the cost, because the different combinations we are making, they are being made based on the technical efficiency, but the decisions what we are making regarding the production, that is also including the economic efficiency, how economically we are using these combination. So, in a diagram we can see that all the combinations R, M, T can produce 200 unit of output, right. Either we use this R point or M or T point, these are the different combinations are given, right. And with these combination, either we are using R, we are using M or we are using T, we can produce 200 unit of firms, and we will try to find out the least cost combination. So, for this it will superimpose the various isoquants line on the isoquants as shown in the diagram. So, where the iso-cost line is equals to the isoquant curve, right. So, that is basically the combination which we are representing with the M, and this is the least cost combination, as here isoquant is tendent to the iso-cost line, right. So, you can also read out here marginal rate of substitution for x and y, right. Marginal rate of substitution, we are talking about how much we are substituting one input over for the another input, like we have labor and capital. So, how are we substituting them with each other? For that we study about the marginal rate of substitution. So, price of x input and the price of y input, we understand this combination, and accordingly we make out the technical as well as economic efficiency combinations, right. So, this is for our today's class. If we revise the topic, if you review the topic, what all we have discussed in our today's session, we have talked about production. Production is basically the act of transformation. We have seen how we are transforming the inputs into the output. Then we have talked about the production function. Production function is the function of the given inputs, right, through which we can start with our production. Then we have talked about production function with one variable, right, when we have two inputs, one is the fixed input and the other one is variable input. So, how we are going to increase the variable input to increase the size of output, and this we have studied through the law of variable proportion. Variable proportion law help us to understand up to which point we can increase our variable input, where we would be getting the increasing return, at which stage we will get the return diminishing return, and if we are further keep on adding a variable input only to increase the size of output, then might be we are getting the negative returns, right. So, this law is very much helpful in the short run to understand how a producer is going to increase the size of output. Whereas, if we talk about production function with two variable, right, this point basically comes under the production function with two variable, that is law of return to scale. Law of return to scale is used to understand how we are going to use the different combinations, right, how we are, because here in this law of return to scale, no input is a fixed input, they both are variable, we can increase the capital also and we can increase the labor also, right. So, how much increase is going to take place in the output? This again with this law we have studied the three different stages. In the very first stage, we have seen a lesser change in the input will causes more change in the output, that is the increasing return stage, whereas in the second stage we have seen the same change, right. The percentage we are going to increase in the input, the same percentage change is going to take place in the output, and that is why that stage is being called as the constant return stage, right. And the third stage, here also we are getting the return, but returns in a diminishing form, where we are using more of the inputs and the outputs which are being increased is comparatively lesser to it, right. And then we have talked about iso-cost curve. Iso-cost curves also help you to understand the different combinations of input which can be used to produce a given level of the output, right. Various properties of quant curve we have discussed. We have talked about the iso-cost line. Iso-cost line is the given budget for a producer for the production of goods and services, and how consumer will be able to reach out its equilibrium, producer is able to reach out to its equilibrium position, where the producer is going to use the optimum utilization of the resources, and this equilibrium reaches to the point where slope of iso-cost curve and iso-cost line is equals to each other. So, this is all for our today's session. These are some reference books for the session we have discussed. Thank you all of you.